one consequence of double angles is that you can actually figure out half angles, they're called. So if you know a certain angle on the unit circle, say you know, for example, let's say that this is pi over 6, you can actually figure out answers like pi over 12 because you can have the angle using these formulas. Now I know there are ways to do angle addition to get pi over 12. You could do pi over 3 minus pi over 4 and do angle addition. But what if you wanted to find pi over 24? You could actually find that by using the answer from pi over 12 to get the angle at pi over 24. So it helps us get a few more angles. Here is the formula, or here's how you get the formula. First start off with one of the three of the double angle formulas. Okay? Now, what we're going to do is rewrite it in terms of sine. So I'm going to, first of all, I'm going to subtract 1. Then I'm going to divide by negative 2. So I'm going to rewrite it like this. I'm doing two things here. I am considering the negative, which is going to flip all the signs. So I flipped 1 in cosine. It is now a positive 1 and a negative cosine. And then I'm dividing by 2. Okay. And then I have to square root now. So there is one tricky thing to this. When you're evaluating half angles, the formula itself does not tell you automatically if it's going to be negative or positive. You have to know that from context. Now this is the half angle formula for sine, and what I mean is, if you were trying to do something like find the sine of pi over 12 or pi over 24, and you know you're in the first quadrant, then after you square root, you know that you're going to end up with a positive answer just by the context, because sine is positive in the first quadrant. So you just have to pay attention to that, and you have to realize whatever angle you're finding, you need to be able to justify whether it's positive or negative based on the quadrant it's in. Alright, so here's what you should be doing. This is for sine of x. Now I want you to try to derive a similar formula for cosine x on the right side. And here you should pause the formula and try to figure out how would I get it in terms of cosine instead. Okay, so we're going to do a very similar thing here. We're going to do cosine of 2x equals, and since it's in terms of cosine, we want to use the cosine double angle formula. So I'm going to add 1. I'm also going to divide by 2. And then I'm going to square root. Okay, so they're very similar. Now the question is, how do you actually use these things? So here's an example of how you would use the sine. Let's say we wanted to find the sine of pi over 12. Okay. So we have to think about this. Theta right here is pi over 12. Now, if I do 2 times theta, I have pi over 6, and we know pi over 6 on the unit circle. And that's important because if I do 2 times the angle, I'm going to be putting it in the formula to figure it out. So what I'm trying to say here is that, in this case, the x here is pi over 12, but when you figure out the formula, you're actually going to use pi over 6. So the real trick is keeping track of what you're going to plug in. So I know pi over 12 is in the first quadrant, and it's sine, so it's going to be positive. Now, I'm going to leave just these areas blank. I'm trying to figure out sine of pi over 12. Now, in the formula right here, I'm going to do double the angle because that's what's in the formula here. So this is where I put pi over 6. So I am finding pi over 12, but I'm using pi over 6 to figure it out. Alright, so the square root of 1 minus, and cosine of pi over 6 is root 3 all over 2 all over 2. Okay. Now that is an exact answer, but I need to be simplifying this a bit. So I'm going to butterfly the inside here. I'm going to have 1/2 minus, and root 3 divided by 2 is over 4. Okay, now I can do a little bit more work here. Now that I have two fractions, I can rewrite this as 2 minus root 3 all over 4. Okay, and then what I can do here is actually square root the top and the bottom separately. So the top is going to stay with this weird, it's called nested radicals, but the bottom, the square root of 4, is 2. Okay, so this is one answer to use the half angle formula to figure out sine of pi over 12. Now you may remember the angle addition formula actually had quite a different way that they wrote this answer. But if you check on a calculator, find the decimal for each, it's going to be the same. It's just written a little differently because of those nested radicals. So I'm going to come back here. I'm going to say you guys should try this out. So instead of sine, you should try something like, can you find the cosine of 7 pi over 12? Okay, you should pause the video, try this out. Okay, so if we put it in the double angle formula, we're going to do cosine of 7 pi over 12, and then over here we're going to be doing the root of cosine of double that angle, so really it's going to be 7 pi over 6 plus 1 all over 2. Okay, 7 pi over 6 is on the unit circle, which is why we can do this. And we have to pay attention to whether this should be plus or minus. Cosine of 7 pi over 12. This would be 12 pi over 12, or just pi. And so 7 pi over 12 is going to be a little over half. It's going to be like right there. Which means, as far as cosine is concerned, this is going to be a negative answer. So we need to put a negative in front. That's what we have to decide. Alright, negative root cosine of 7 pi over 6. On the unit circle, 7 pi over 6 is right there, which means that it's a negative root 3 all over 2 plus 1 all over 2. Alright, and now we're going to simplify this. We're going to think of this as negative root 3 all over 4 plus 1 over 2. Okay, and then if we combine these, it will be negative, and I'm going to rewrite it as 2 minus root 3 all over 4. What I'm doing there is I'm turning this into 2 over 2, and I'm flipping the order. Sorry, 2 over 4, and then I'm flipping the order. This would be negative, and if I root the top and bottom separately, I will have negative 2 minus root 3 all over 2. That is equal to cosine of 7 pi over 12. Alright, so this is kind of cool. You can do any angle that's halved of what we already know. So we already know, for example, back here, sine of pi over 12 is this. So as a challenge, what you guys can do is you can figure out what is sine of pi over 24? Or better yet, what is sine of pi over 96? Because I'm thinking 24, 48, 96. I'll leave it up to you guys to see whether you would like to try that.